Okay, well, I think I'll get started. I have a few more folks that hopefully will be joining us soon. It's nice to meet you all. Um, I'm going to go ahead and open us up in prayer. That's usually what I do beginning of my classes, so start with that. Dear Heavenly Father, Lord, we just invite you here in our midst. So, Lord, I pray that you would be working in the lives of each of the students in this course. Lord, I pray that the material will be clear, that folks will be able to understand the concepts and see how this is related to what they would like to be doing in their future in their chosen profession. Pray you'd also help them in their spiritual formation, Lord, that each of the students here can actually understand the magnitude and wonders of of Scripture to get a better sense of the theological concepts in which we want to draw from that, Lord, and give them interesting and creative ways for faith integration. In Jesus' precious name we pray. Amen. Well, what I'd like to do today was to give you an introduction to the course. And so I'll just walk through a few charts in terms of some of the lecture notes. Then I'll go over to Canvas for a little bit, and then I'll go back to what I'm going to show here and the lecture notes. And so in a general sense, Tuesdays will be more focused on lecture, and Thursdays will be more focused on more of a lab environment where we'll be doing coding. And so you'll get a better sense of what that is going to be like. And so this is our textbook that we're going to be using, Data Structures and Abstractions with Java. It's actually a pretty good textbook, and there's other resources that I'll be leveraging pretty heavily in our course, the video content that's related to this. And so that'll be stuff that we'll have. And so this is just a little bit more information on the textbook. I've also made these lecture notes available on Canvas, and so you can feel free to download them and peruse them as you would like. They're not a substitute for the textbook, but they are complementary, and it'll give us a chance to be focusing in more detail on some of the the coding part of what we'll have in our class. And so this is a few of the links. And so with the lecture notes that you have, these are active, and also have a lot of things in Canvas that you can be looking at that. And so there's a variety of student resources as well as these video notes, and there's like 2 or 3 video notes per chapter. And so these are things that are like about 5 minute long. But I find that since they are real time, it's dynamic. It's not just static like the PowerPoint charts. And so I will be using those to help us navigate through the course material. And so we have a variety of chapters, about 30 chapters that we'll be covering during the class. So in a general week, we'll be covering at least 2 or so chapters. And so most of that content will be on Tuesdays, as I said. Since we're doing this with Java, we'll have these Java interludes that show that how we're going to do that implementations in a particular language. And so data structures or stuff that goes across the board. I could be teaching this in C++ or Python, but here at EPU, we tend to do a variety of our courses using Java, at least in the beginning level, freshman and sophomore level classes. And so I'm just going to be following along with that general tradition. So I'll just do an introduction, then I'll flip over to Canvas and highlight a few things there. And so basically, when we're thinking about data structures, we're thinking about ways that we're organizing information in our lives. And so things that we're familiar with, standing in a line or having a stack of books, a to-do list, using a dictionary, having the various directories and folders that are on our computer or a roadmap. These are all indicative of a type of a data structure that has certain types of rules and how you're going to be leveraging that. And so we'll get a chance to be seeing this. And so we're going to create data structures that only have these kind of characteristics, these requirements for different data structures. And then we'll be starting to think about, well, when would it make sense to use one or another? And so with some of our project work, I think that'll start to become a little bit more familiar. So we will be introducing this idea of abstract data types. And so when you implement a ADT or abstract data type, you create a data structure. And then when you're using it, you have a collection of elements that's obeying the rules of that data structure that is leveraging that abstract data type. And so we're going to have 7 that we're going to be talking about in this course. And so the first 5 are ones that you'll be doing coding, and then there's extra credit for folks that would like to get a chance to get some hands-on doing a tree and a graph. Those will also be there. And so if maybe these words mean stuff to you, and so for a bag, you can think of like a grocery bag going to the store. It's fairly straightforward. That's a type of a abstract data type. A list, that's something that's more capable in terms that you can have there's a relationship between number 1, number 2, number 3 on that list. We have stacks and queues that have a characteristic where there's limited information that we can do with it. So by a stack, you can only get things, that are on top of the stack. And so if you wanted to get what's on the bottom of that stack, you have to take all those books one at a time till you get to the bottom. A queue is in the reverse order. It's whoever comes in line first is the one that you get a chance to service. A dictionary has a relationship between a key and a value. So it relates to different things. And trees are quite interesting, and I want to make sure that we spend enough time to at least introduce those concepts for you all to be seen at. You can think of a family tree, an organizational structure. Those are examples of trees. And a graph, if we were teaching this in C++, they would be calling those maps. And so maps is an example of a graph. And so you can be thinking about that. Well, this is a chart that I made that sometimes we get visitors coming into the course. And so if I had to introduce this course in one chart, this would be the chart that I would be using, trying to capture the various things that we're going to get a chance to talk about. Now, I put these in red, all the abstract data types that we're leveraging, and I put list down here because this is the order we're going to be getting a chance to be exposed to them. First a bag, then talking about a stack, and then a queue and a list and a dictionary. We'll spend some detailed time thinking about those. And like I said, we'll also talk about these very important but more capable types of data structures, the tree and the graph. And so the way the textbook is organized is that there's concepts that are introduced early on, and then it comes back and we see how that is actually used as we get into more and more complication. So there's a variety of things that we'll get a chance to be thinking about. First of all, data access. And so we'll be thinking a little bit about from a cybersecurity point of view, a user or a client for the code that we're developing. You want to give them access to what they need, but not access that is meant to be on the back end side. We'll introduce this idea of an interface. And so hopefully fairly soon, you'll get a chance to understand the strategy. And so we're going to be developing something that's called an interface. And it's called different things in C++. And so basically you're providing a indication of what are going to be the methods that you're going to be using in your code without doing the implementation. So the implementation is something different. And then we would want to make an application for this. And so if we're going to have a bag, let's pretend like we're working for Amazon. So we're going to be making a shopping cart. And so we're going to do an application for a shopping cart that uses the blueprint that we lay out in the interface, and then we do an implementation. We'll be talking about various ways of things that we can be using for implementation. We can do things in array. You guys are probably fairly familiar with an array, just a variable that can have so many elements. You know, a lot of times in computer science, it starts with item 0. Or we can also have something else called a linked implementation. So basically from one, you have its contents, but it also has a link to go to another one. You can think of a chain. And so the links of a chain might be a way of thinking about that. We'll be talking about a couple different ways that you can actually do some implementation of coding. You can either do in an iterative fashion. That's probably easier for us to understand. You go from one to the other all the way till that you're done. Recursion is a different type of programming, and this image here is trying to pretend to give you a sense of recursion. So you break it down into a smaller problem, and then you keep calling that same routine again. You calling the same routine again and again. Anyone have ever heard of recursion? Have you ever dealt with recursion? Okay, so at least you've heard of it. Maybe you dealt with it. Then we'll start to be thinking about things like sorting. We'll talk about a sorted list, for example. And so as things get more complicated and you want to have access things quicker, that is one of the ways that you can actually reduce the time it takes to find something. And so that gets into searching. We'll be talking about algorithms and performance. Different algorithms perform better than others, and so you'll get a chance to see some of that. And we'll be thinking about considering the various types of approaches that you can be doing in coding. So that's just a quick introduction to some of the stuff that's I wanted to make sure that I spent a few minutes on talking about before we get into some of the further details. But let me click over to Canvas and share a few more details, things that I've made available for you. So Tuesdays we'll meet in person. Thursday, because I'm trying to make it a little bit more of a lab environment, we'll be meeting via Zoom. And so the intent is I'd like you to be having your laptop so that you're going to be actually doing coding with me. And so as we start to do these various ADTs and doing implementation, you have a copy of the lecture notes that I'm showing. What I encourage students to do is to think about a certain type of data set that you might be interested in. And so people have done things from hobbies, maybe they're into movies. One or two people did things related to, say, like a wedding planning or something, like the various things that related to that. Video games, or it could be if there's some types of sports. One person did a Tour de France, and so they were trying to look at different ways of, it's a team sport, and so you have like one team that has 10 riders, and so you can have things that related to them as a team, but you have the people as an individual. So one person might win the first day of the races, and so there would be the lowest time, and so the first rider. But as there's like over a month period of races that they do, you can see that there would be having people would have that they win a certain day, but they may not be in first place overall. So it's a more interesting data set that you can start to be thinking about. And so just begin to think about if there's something in that area that you might be interested in, and you might want to be doing some coding in. So it could actually be a real data set. I mentioned the Tour de France already. It could be whatever events we're getting done with football season. Maybe you might want to do something with that, or baseball, or we'll be going into the Olympics in the summertime. So there's just the sky is a limit in terms of what you might want to be thinking about. So those are some of the resources. There is here as a sample bag source for you to download. And so it's a zip, and then you want to import that into Eclipse. Have you guys all used Eclipse? Are you familiar with that? So I'll show you that on Thursday. So that's a couple things that I wanted to point out. I do have video lectures that I've recorded in the past that go by chapter. And so those are available. I also have the 0 one. This is some videos that have been done that talk about how to develop Java programs in Eclipse the way that we're going to be doing it, where you're using an interface. And so you can feel free to take a look at these videos, and I think it'll help. And so this is something that I'll be going over more on Thursday, but by Thursday, make sure that you have your Eclipse environment up and running. Definitely download this zip file and see if you can go ahead and import that into your Eclipse environment. And I will go through this with you. And so this will be a heads up for your first project. And so you want to be thinking about what you want to be working on in terms of a data set. And then start to put this into your Eclipse environment. There is an option if people get real stuck and they're not quite sure what they might want to be doing for a project. There are some various things here in this course project that is another alternative that individuals can utilize. So the syllabus is available on the syllabus task, and so you can get a rough idea of the breakdown. So the course project is about 1/3 of the grade, and so there is a final, but we do a lot of these quizzes, chapter quizzes and review quizzes that are the lion's share of what is going to be in the class. And so there's a quiz for each chapter, and I think there's 4 or 5 review chapters. The chapter quizzes you can take as many times as you would like. The review quizzes are a one-time in, so definitely want to spend a little bit more time preparing for that. And plus there's a participation component for this. Any questions on that? Okay. So the Zoom link is right here on top. And so for Thursday, that would be the Zoom link that we will be using. And we'll get a chance to take advantage of that on Thursday. So one of the modalities that I mentioned was that I'll be taking advantage of some of the video notes that we have here. And so I'll show you some of that. But let me just do a little bit more introduction with the lecture notes, and then we'll come and I'll get a chance to introduce what those video notes and how they make a nice complement to the material that we have in the other resources we have in the course. Okay, so we did an introduction. We gave a little bit of introduction that we're dealing with abstract data types. We're going to be building data structures and then looking at the collections of when those things are in action. And so next thing we wanted to be thinking about, how are we going to go about designing classes? And so there's a couple different techniques that we'll be leveraging. We'll be using something called encapsulation. So you put things into a logical unit. We're going to be specifying methods. And so you remember, like, classes are sort of like a noun. Methods are like verbs. And so the nouns do what the verb tells it to do. And so you're creating verbs that then the nouns, what the classes are going to be doing. Well, we're going to introduce this idea of an interface. And so this is where we come back to this chart that I just showed you, where we have this the structure where what is being given to you as you're doing this programming, you're saying that you have to implement your code with these methods. You can make more methods. And when we start to look at the sample code, there'll be various examples of that taking place. But it's trying to tell you that definitely you're going to be using these minimal complement of interfaces, these methods in these interfaces. We want to be starting to figure out how we're going to determine what's going to be a class. And so that depends on what area of things that you're going to be coding. And so we'll introduce something called a CRC cards. We'll look at how we could be laying things out in UML diagram. And so those are some of the high points that we'll be talking about. So we're going to be, Java is an object-oriented program language. And so that's what we're going to be doing. And so we're going to be using these features, encapsulation, inheritance. You've been hearing me talking about that. And polymorphism, which means poly, many forms. And that's what we're going to have our code. And so you can have a method name and say you have no variables, that would be one method. Maybe you have another method and it has some variables, that would be an example of two morphs, two versions of that method that we're making available. So encapsulation is useful for information hiding. And so this is like a cyber security perspective. There's things that you want to make available to the user, other things that are not necessary. You want to make sure that you keep your data intact. You don't want to have the user accidentally manipulating that data set that you're trying to make available for them and potentially others. You're hiding the implementation details in the next chart that I'll show you. It will give you a better sense of something you're familiar with and why it's useful. The programmer receives only enough information to be able to use the class. And so let's think about driving a car. So I don't need to know the type of engine. Does it have fuel injection or various other types of parameters that are there? These are this is the interface that a driver has. So this is what I'm trying to say. And so this is the things that would be exposed to the user. A steering wheel, all of the different gauges, a way of being able to shift and forward and reverse, and a gas pedal, a brake. Those are the types of things that are required for a car. Let's say that I want to do something else. And so I'm going to put in an entertainment system. That would be an example of you doing additional methods that's going to be part of what you're creating that aren't necessarily required for the basic performance. But you can see nowadays that people wouldn't buy a car if they didn't have an entertainment system, right? And all these other feature comforts. So that's something that we're fairly familiar with. So, so in terms of abstraction, we focus on what instead of how. And so what needs to be done. And so we're starting to see this distinction here. And so we can divide the class into two parts, the interface and the implementation. So that goes back to, once again, this chart here. We're making this distinction between what the user is going to see that we're making available in the application versus what we're implementing in terms of the data structures that we're trying to leverage. So here's a different way of looking at it. And so the client has things made available to them. So the steering wheel, the gas pedal, the brake, stuff like that. And the implementation is how we're going to actually do the detailed coding for each one of those things. So there's other things that we need to be laying out when we're doing the methods. What are the inputs? What are the outputs? And other types of things that we'll get into, including something called an assert statement. If you haven't heard of that, that's something that we'll get a chance to touch a little bit later. So we'll be using these interfaces. C++ uses headers. We're using interfaces as a way of clarifying what has to be implemented if we're going to be doing, using some of the characteristics of things that we're developing. And so that's what we have here with our interfaces. And so this is an example of what an interface would look like. You have this keyword here, interface. And so here you have a class measurable, and then you have methods, but you don't have any details. You just have the names of those methods. And so we're going to be talking about starting on Thursday. We'll show you a shorthand way of how you can be creating a code stubs by using an interface, and then you'll then have those code stubs, and then you have to do implementation for each one of those methods. So here is an interface. Here is another interface. This is the name interface. This is the measurable. And so we have two interfaces that are laid out here. And now we're starting to see some details being laid out here. So we have an interface, measurable. And so if we want to implement that, so this is what we would have, a public class circle implements measurable. We can have a different one for square, public class square implements measurable. So there's going to be a certain handful of methods that we're saying have to be implemented. And so this is how we're making it happen. And then the client would do an instance of having a circle and a square, and then we have some sample code. Those are things that would then be laid out with that. So implementing an interface, it's a way for programmers to guarantee a class has certain methods. I've mentioned that. Several classes can implement the same interfaces. We saw this in this chart here. We have circle and square, and a class can implement more than one interface. We haven't seen that yet, but that is something that is possible. And then you have to implement all of the methods from, if you have two or more interfaces, all of that would have to be done. And the Java, when you do a compile, it's going to be validating that and helping you figure that out. So I think those are some of the highlights that I wanted to point out for here. So when we're choosing classes, you want to be thinking of, well, who is going to be using what? What are they going to be do? What are the scenarios that we're going to be laid out? And so here's an example of a use case diagram. This is something that's used in UML as well as SysML. And so here you have two classes, a student and a register. And so the student can apply for admission, can enroll, can add a course, can drop a course, can display their courses and change their address. And a registrar can do most of those things, but as would make sense, they're not applying for admission. You could argue other functions that go beyond this, but you're trying to focus on the registration system. And so this would be a way of starting to lay this out. These would be the classes. These would be the methods that you're going to have to come up with a naming convention for laying those things in a logical fashion. So this is just doing it in an outline form. And so we're going from this type of a diagram to an outline. Then we could start to maybe begin to finesse this a little bit more. And there's something called a class repository collaboration, a CRC. And so now we have the nouns, we have the verbs up here. This is what they're going to be doing, and this is who's going to be doing it. And lastly, we can have it in a unified modeling language. And this is what it would start to look like. And so we can have a course list, a course count. And then we can have, these are the various methods in the Campbell-back format that's showing you what's out. So these are the variables. This is the verbs, and so these are the methods. And so all of that is, we see how that is working out. From a UML notation, this is how you would show what an interface is. You have these angle brackets and the term interface versus having class. And so that's what that would look like. And so here we're from a UML, we have a student, and then we can be more specific. We can have an undergrad student or we can have a grad student. And thus we can have a hierarchy that can be laid out from that. Okay, I'm going to switch over to the video notes so you can get a chance to see what that would look like, since that's going to be one of the things that we'll be using on a regular basis. So go ahead and just try this first one and see how my sound is. So I'll be mixing these up with the lecture. And so we'll go a little bit back and forth between these two modalities. Okay, give me a second. Try this.
Have to where it says when you go a little bit more down in output input. Yeah, a little more down. Yeah, you're already on that's input. You click output.
Sorry.
Then you could probably click on crash.
Yeah, sorry about that. Give it a shot now and see if it works.
This lecture builds on the foundation of the object-oriented programming concepts of encapsulation and data abstraction, and it helps develop the notion of an abstract data type. As you probably know, a data type such as an integer or double is a group of values and operations on those values that is defined within a specific programming language. In contrast, an abstract data type, or ADT, is a specification for a group of values and the operations on those values that is defined conceptually and independently of any programming language. A data structure is an implementation of an ADT within a programming language, and this lecture also begins to generalize the idea of grouping objects together.
So I try to mention this a little bit in the lecture, and this is like what I'll do is I'll be showing the video, but also engage and interact with it. So we have these three concepts, an ADT, data structure that is using that, and then a collection. This is where it's something that turns into, makes it real.
Collection is an object that groups other objects and provides various services to its client. Various collections exist for different purposes, and we're going to specify the behaviors of collections abstractly. So a collection is an abstract data type. However, an abstract data type is not necessarily a collection. For an example of a collection and of an abstract data type, let's look at the abstract data type bag. A typical collection enables the client to add items, remove or retrieve items, and query the objects it represents.
So this is a graphic, and it's also trying to give you an idea, just a bag. You know, we think of a list or something, it's in our minds, but you're trying to just create a focused, limited capability because there's examples, because that's all you need. You don't need to have it listed. You don't need to know what the third item that was put into the bag. You just need to know if that's in the bag. And so this just gives you an idea.
Let's look more closely at the specific behaviors our ADT bag needs. We need to check the bag status, so we need to get the number of items currently in the bag and see whether the bag is empty. We need to be able to add a given item to the bag, remove an unspecified object from the bag. We need to remove an occurrence of a particular object from the bag if possible. And we need to be able to remove all objects from the bag, such as when we want to empty or clear the bag.
So for each of these five, actually each of these 7 ADTs that we're going to talk about in classes, the first thing that they do is they tell you in words or defining the requirements, what are the characteristics of this abstract data type? It's going to be 2 or 3 steps before they then do it in the code. In the beginning, it's going to be very detailed. And as we go along, it'll be less detailed because you started to get a better sense of what we're doing. So this is, we're going to go through in a very detailed sense of getting a chance to understand a bag.
We need to count the number of times an object occurs in the bag. And we need to test whether the bag contains a particular object. Finally, we need to be able to look at all the objects in the bag. We can take these behaviors and write them on a class responsibility collaboration or CRC.
So we can see the first step is we just list it, maybe in an outline. One possibility, if we want to, we can then go to the CRC list. The next thing we're going to talk about is UML. So we're starting to see this progression.
Since a bag is an abstract data type, we only describe its data and specify its operations. We don't indicate how to store the data or how to implement its operations. For example, when we think about arrays, we first need to clearly understand what the bag operations do, not how to do them. That is, you need a detailed set of specifications before you can use a bag in a program. In fact, when we design ADTs, we should specify the ADT's operations even before we decide on programming. Before
Make it a little louder.
we can implement a bag in Java, we need to describe its data and specify in detail the methods that correspond to the bag's behaviors. We'll name the methods, choose their parameters, decide their return types, and write comments to fully describe their effect on the bag's data. Our eventual goal, of course, is to write a Java header and comments for each method. But first, we'll express the methods in UML, or Unified Modeling Language notation. As behaviors, our methods should begin with action verbs. For example, when finding the number of items in the bag, we get current size.
So this means that there's something that's going to come back and it's telling you what type. So it's going to come back as an integer. So just to give you a better sense if you're not following that part
This
yet.
method returns the number of items, so it should return an integer type. It doesn't need any parameters since it operates on the bag itself. Similarly, isEmpty does not need any parameters. This method is only checking the status.
Boolean, it's either true or it's not. So is it empty or is it not, right?
To the bag. As a predicate or yes/no question, it can return a Boolean value. To add an entry to the bag, we can call our add method.
So we're going to get into this on this T. We haven't touched on it yet, but we're going to talk about a generic type. And so just keep that in mind, but I'll come back to that. Also, this little plus, that actually means something too. It means public. So anybody can access to that. You can have private, you can have package. But this is something that we're going to start out by just having everything as public access.
It needs a parameter of the type of object we're going to store in our bag. For now, we can use a generic T to represent that type. Here we have an interesting design issue. What should the add method do when it cannot add a new entry? At this point, we have 2 options. First, we could do nothing. We cannot add another item, so we ignore it and leave the bag unchanged. Second, we can leave the bag unchanged, but signal the client that the addition is impossible. The first option is easy, but it leaves the client wondering what happened. The second option is a better one, and it is easy to specify and implement. Displaying an error message is not a good choice since a class should let a client manage all written output. Since adding an item is either successful or not, we could simply have the method return a Boolean value at this time.
So we're getting ways of doing some diagnostics, if you will. Does it come back true or not true? So maybe it's not an error message, but we can also see what's going on. So that's some useful information. And so it's better to do it that way than just throw it over the fence and you don't know what happened.
Later, we'll examine using exceptions to notify the client. The first remove is easy. We could just have it return the item removed. If the bag is already empty, our method can return null. Since the client doesn't know ahead of time what item is going to be removed, the return of an item is important. The second remove method requires us to specify an object to be removed. If the bag does not contain the item, we need to inform the client. Since the client already had to specify the item as a parameter, we can return a Boolean to indicate whether or not the item was successfully removed. Removing all the bag's contents can be a void method.
So you understand the difference between these removes? It's like, you're have everybody put their name into a hat and you just pull it out. You don't know which one it is. You just literally put your hand in there. That's like this first one. The second one is no, you're looking for a particular item, an apple, an orange, banana, or something like that. And so you have to scrounge around to find it, and either you do find it or you don't find it. And then clear, there's nothing that you return. And so we just take everything out of the bag.
We just want to empty the bag, not retrieve any of its contents. The next two methods report on a specific item and don't change the contents of the bag. Then finally, we want to look at the contents of the bag. Rather than providing a method that displays the entries in the bag, let's define one that returns an array of these entries. The client is then free to display any or all of them in any way desired. This design decision makes our class more portable and independent of display methods, such as needing to determine if the application is console or GUI based. As our specifications become more detailed, they can increasingly reflect our choice of programming language. At this point, we can write Java headers for the bag's methods and organize them into a Java interface for the class that will implement the ADT. Remember that a Java interface does not have fields, constructors, or private methods. For now, the items in the bag will be objects of the same class. For example, we could have a bag of strings. To accommodate entries of any one class type, the bag methods use a generic type T for each entry. To give meaning to the identifier T, we must write T in angle brackets after the name of the interface. Once the actual type is chosen within a client, the compiler will use that data type wherever T appears. Here's the syntax example implementing the generic interface, bag interface.
I have given you as a zip in Canvas all of the interfaces that you'll be using. And so that's something that is readily available that you can be having. So there's all 7. You're definitely going to be doing the first 5. This last 2 are extra credit. And so keep that in mind. There are a couple nuances when we get into, say, like queues, because you can have queue, you can have deck and priority queue. And so I also have those as well. There's a slight nuance differences in the interfaces, but you'll see that in a little bit. So this is, once again, it's specifying certain criteria that must be met in your implementation. So I've had some students, they didn't use the interface. And so I want to give you advance notice, please do that. You can resubmit if you did something and you forgot to use that, but make sure that when you're doing your code implementation that you use these interfaces that we've made available to you.
The class bag must provide an implementation of all the methods we're about to define in the interface bag interface. When we're ready to instantiate or create a bag object, we specify the type of the item we want to store in the bag. In this example, we're storing string objects in our bag. Our methods that check the status of the bag are independent of the type of items stored in the bag. The add and remove methods use the generic type T for the entry to add or remove from the bag. Since we're not worried about implementation details yet, How these items are stored and removed is not important to us. And last, we have the methods that check the status of a particular entry stored in the bag and the to-array method that returns an array containing the entries in the bag.
One of the things you're seeing, all these green lines here, these are the things like if you were to actually use something that's built into Java, we're not using things built into Java with these particular interfaces. This is the kind of things that's setting it up. So if you're starting to use something in Eclipse, it'll start to give you hints of like what you're supposed to do with this, what you're supposed to return and things like this. And so that's just something that you can keep in mind. All of these are different @ signs. These are some things that the Java and an IDE will pick up. Okay.
Just because this method returns an array of the entries does not imply that the items are stored in an array data member of the ADT bag. How we store these data items is an implementation detail and the topic of another lecture.
Okay, so that gives you an idea of how things are going to be done here with our classes, and what we'll have as a general flow. So we'll have the lecture notes, we'll have the video notes, and then we'll be doing mostly coding on Thursday. So here is some things I'd like you to make sure that you do. So download the sample bag source, okay, and have that installed in your Eclipse environment on Thursday, and I'll be doing a virtual around the room to help you out with that. There's also the source code that's made available for students, and so this is all the code that's in the textbook, and so you can be leveraging that as you're starting to write some of your projects. Please feel free to take advantage of that. And there's also here is a zip of all of the interfaces. So the bag interface.java, for example, that would be the first one that you'll be using. And so you want to make sure that you download that as well. Okay. Any other comments or questions on that? Okay. Well, let me do this last video note just to finish up for today. And because it's still on topic. And so we talked about designing an ADT and then designing a test for an ADT. So this first one, we laid out setting up everything you need for the interface. And now let's beginning to think out how we're going to make it testable. First part's too loud.
This lecture introduces testing methods that can be used to test implementations of abstract data types. Testing is one of the most crucial activities in software development. Any code we write or modify needs to be tested before it can be used in production or live systems. There are two important goals to testing. First, testing ensures that our class behaves as written in the specifications. This is called verification. The classes that we write are used along with many other classes to create a program, and each individual class has specific actions that it must perform so that the overall program runs correctly.
I'll introduce a coding strategy. This is actually, I've had students, say about 50% students have a difficult time in this course. So just giving you some perspectives about it. So I always try and encourage students to go from working code to working code. So try and implement one method at a time. So get a basic construct that's working. It may not be doing what you want, but it just returns a print statement or something like that. And then do one method at a time. I want to have you thinking about that. And so this gets a little bit into testing strategies. And so there's a course that eventually you'll be taking software engineering. And so that's one of the things that starts to come up, that how robustly you're going to test to make sure that something is actually functioning.
If the class does not meet its requirements, other classes that use this class as a data member or client may fail to perform successfully also. So when an item is added to our collection, in this case, our bag interface implementation, we need to verify that the item was added. When a specific item is removed, we need to verify that the requested item is removed. The second important goal of testing is validating that our class has no errors. Our implementation must work as expected and not lose or modify data outside of its responsibility. The data structure that implements an ADT should be consistent. When items are added to the data structure, they should be added and not lost or break the data structure or how we track items inside the data structure. Testing methods, classes, and programs should always follow some type of plan. Never do haphazard testing. Without a plan that tests and validates an ADT implementation part by part, it is extremely difficult to pinpoint exactly where an error occurs, and so we may break code that was functioning correctly or duplicate tests expecting different results without changing the code that caused the actual problem. A good test plan focuses the testing so it is clear where errors occur or improper behavior breaks methods.
So that's why doing one method at a time can be quite helpful, because if you've got a method and it's working and then you're not touching that part of the code, then you're developing another part. And so you're building this mountain of successful code.
There are two methodologies we can use to develop a good test plan. The first is unit testing. In unit testing, we focus our testing on the implementation of specific classes. We want to ensure the class performs as required. By focusing on one class and its specifications, we know that any errors that arise are in this class. Once the class is thoroughly tested, it can be used with confidence in programs and other classes. An important tool in unit testing is the test harness or driver class. This is a class or program that is designed to test a specific data structure and calls all of the data structure's methods and tests them to ensure that the data structure performs correctly, even in extreme situations, such as when our bag would be full and we try to add an item, or when the bag is empty and we try to remove an item.
Okay, during the class, I'll be talking about driver programs as well as applications. And so a driver is just that, it's just checking all of the methods. An application is what you're doing with your project. It's serving a purpose. It's not just seeing that the methods work. It's actually, if you're doing for a wedding plan, that everybody successfully was able to register what gift they're going to get or something like that, or said, yes, they RSVP'd and they're going to be going to the wedding. And so you see that that functionality is working. It's like a layer above that driver program. But so this is what they're talking about. So when you're starting to do your code, you want to have a way of thinking that through. And what I'm arguing would be a good way is getting one method at a time, getting it functioning, and then you can go to that higher level.
For unit testing, we implement our code in pieces and test each piece before implementing additional functionality. For example, we decide to test the data fields for the class and then implement methods that provide core functionality, such as constructors and methods to add and display items. Then we test those methods before continuing. Next, we implement one or a few methods that are more involved and test those. Once those pass our tests, we continue implementing and testing additional methods until the class is complete. It is crucial that this iterative approach is used even now. Implementing ADTs require classes that are more involved than you may be accustomed to. The programs are going to be more complicated and require more classes also. Implementing and testing code in small parts saves hours of debugging time. System testing follows unit testing. System testing tests how classes work together. This can be done with several related classes, such as those that form a package, or it can be all of the classes that form a program being tested together.
So this is like a higher level function of your application. So first of all, you're making sure your methods work. Now you want to figure out how they aggregate together to serve what you're trying to do with your code.
System testing often relies on the use cases that were developed during the design phase of building a program. The classes that comprise the program are tested in workflows that would occur during the use of the program. Unit and system testing methodologies guide us in designing our tests, but what exactly do we test? This is where the idea of black box testing can guide us. Black box testing treats the class or data structure being tested as a black box that we cannot see inside. How the black box is implemented is not important, only that the box functions the way it is specified. When the box is fed a certain input, it should respond with a specified output. In black box testing, we are only concerned with functionality of the box or class and the interfaces to it. This means that we can test our data structure based on the interface that it implements, since how that interface is implemented is not important. The implementation is not important to the testing, but the implementation is important when it comes to fixing any errors or bugs and resolving any
So if I'm testing a car, I'm taking it out, driving around the block, see if everything works. If it has certain characteristics that it's supposed to go to a certain speed, it's supposed to have, good shocks, and it keeps things fairly stabilized. Those are the things that I'm checking in that overall level, black box. All I have access to the things that any driver would have access to. How it's actually implemented behind the scenes, that's not important in that kind of a sense. And so that just gives you another example of where this interface can be a useful thing. This is what you're exposing to the user, okay? So we're going to be doing application programming. We're also going to be doing back-end programming. So we're going to be doing a couple different types of programming in this class.
inconsistencies the testing discovers. And black box testing can be used for both unit and system testing. Now let's look at some of the specifics of developing tests. First, for unit testing, we want to validate the status of our collection after we've added or removed items to our data structure. We want to ensure the bag is full or empty when it should be full or empty. And we want to display all of the items in the bag to validate that each item that should be in the bag is actually in the bag. We also need to validate the status of individual items as we add and remove them. This is a different problem than validating the status of the collection. For example, we may check each item after adding it to the bag and validating that it was successfully added, but the bag may return that it is still empty. In testing any of our ADT implementations, we want to make this distinction between testing the success of adding or removing individual items and validating the status of the entire collection. With this in mind, we can begin to develop a unit test plan for our ADT bag implementation. Let's focus on the methods themselves and see how we can test the functionality of this class. To start, we need to create an instance of a bag to test. A newly created bag should be empty, so we need to check that. Next, we can add items to the bag and validate that the bag has all of the items added. And also check that each specific item is in the bag.
So this gives you some hints of how you're going to start to be testing your bag program. That's the first one you're going to be doing. So just among you guys, anyone want to throw out an idea for what you might want to do for your project? Maybe I can make this a little bit more real. Or if you're not sure of exactly that, or just a rough area, anybody want to throw something out? Sorry? Okay, football playoffs. And so you can be thinking of a lot of different parameters. And so you're going to be having information for 32 teams. What was their actual performance? You could say just, how many games they won or lost. Did they have a trend of how many they won or lost? What is their quarterback rating? What are some various kind of parameters that you're going to start to be thinking about? And so maybe we're getting into the wild card weekend or something like that. So who got to that level? And then you could start to be thinking about, so who actually got into the bag? So those are now the potential players that are going to be going on. So that would be an example of something that we could start to formulate how that works. Some people got in, some people surprisingly didn't get in, came back down to the last game. Other people have been known for several weeks that they were in because they had done that well in the season. So with that, you could start to be thinking about that. So maybe they sort of give like a hypothetical who's actually in the postseason, and it says based on how they performed up to this point, this is where it's going, but it's not finalized. So something could go in the bag and it could just get out of the bag because of a new development that comes in. And so those would be, say, some examples that you could start to lay out. So you can see does that help to give you a perspective of what an application related to something that you could be doing, how that would be playing out? And so you're looking at how these methods produce results, feed that back based on what you know should be the answer, because you have a test, you have a testing set of data, and then you have, I should say, your validation set of data, and then you just have, after that, you just start to look at it in general, because it's after it's past its validation phase, and you can actually use it, okay?
If the items we added were added successfully, we can remove random items and then specific items from the bag. Then we can continue adding and removing items, but we want to validate two important boundary conditions: that the bag is full when it should be full, and that the bag is empty when all of the items have been removed. This is a different condition than when the bag is first created and is empty. Now that items have been added to and removed from the bag, if our internal accounting system for the bag has an error, the bag may not realize that it is empty. Three important methods we need to be aware of are the add and to remove methods. These methods change the state of the bag. In our test plans, we want to ensure the status of our data structure is validated anytime methods that change the data structure's state are used. Here's a skeleton for a driver program that can test an instance of our bag class that holds string objects. The code for the specific test goes in the main method, and there are several helper methods shown here in orange that can be called to perform tasks we need to repeat several times. A very important aspect of this driver class is that we use the bag interface instead of the specific bag implementation as a parameter to the helper methods.
One of the reasons why using this is helpful, if you change your implementation, you try it one way, it works, or it doesn't work exactly, you can create another implementation, and you don't have to change other parts of your code.
This generalizes our driver so that it can be used with any bag interface implementation that holds string objects. We have a set of helper methods that shows us the status of the bag. Show bag stats calls get current size, and then reports those to the user. The display bag method calls the bags to array method and then displays the items in the bag for the user to validate. The add to bag and remove from bag helper methods add and remove items respectively, but also validate that the correct item was added or removed. Looking in detail at the main method, we step through a series of tests that use the helper methods to manipulate and validate the bag. Here we instantiate our bag. Since we are performing black box testing, we are only interested in the interface's functionality, so our test bag is of type bag interface. We cannot instantiate an interface, so we instantiate an object from a class that implements the interface, the class we want to test. After creating the bag, we check to make sure it's empty and display its status. We then add values to the bag and display the items to ensure they were added correctly. Then the bag is empty or cleared, and we add items and check each one after we add it. Following that, the status of the entire bag collection is checked again. With several items still in the bag, the remove methods are tested. Either a random item is removed or a specific item is removed. If a specific item is removed, it must be checked to validate the correct item was removed. When our bag implementation test driver is run, we see testing output that shows the activities our bag was put through, the bag's status at various points in the test, and validation of the adds and the removes.
So some of the code I'll be showing you on Thursdays will be drivers, because I don't know what your application is. And so you guys are writing that. So I'll be going to that step, to that first level, validating the methods. But you're gonna have to go to that step further of trying to figure out how it's gonna be working for your application. And so we'll see stuff like this. And the sample code that I shared with you for the bag implementation will have a driver program that is at various levels of development.
Once we are satisfied that our bag implementation has passed all the tests and we believe it is functioning correctly, we can do a system test. We combine our bag implementation with several other classes to create a program that performs some real-world function that requires our class. In this example, we create a piggy bank that stores coins. The piggy bank holds all of the coins but does not organize them, and there may be duplicates. So our bag class is a good abstract data type to use as a data member. The piggy bank class can then be a simple wrapper that lets the client add coins to the piggy bank by adding coins to the bag, removing random coins from the piggy bank by removing a random item from the bag, and then checking to see if the piggy bank is empty by checking to see if our bag is empty. The data member is of the type bag interface. This gives us flexibility in what implementation we use to hold the coins in our bank. In the constructor, we instantiate a bag implementation. If later we find that a better implementation of bag interface exists, we only need to change this one statement in our class to use that new implementation. Here's a program that uses our piggy bank class to add and remove some coins. We declare a piggy bank object here, and even though we appear.
So this is another example. I won't be highlighting this one for starters, but this is another sample code in Eclipse that I can be sharing with you to get an idea how it works of doing a piggy bank. I actually would argue it's a smart piggy bank with some of the things that it can do. It can actually tell you more about the information that of the coins that are being put into it. And so we have methods, and then we have other methods that we can validate that it's actually doing what we would like to do. So this gives you another example of that higher level testing that you can be performing.
Here to be testing our piggy bank program and piggy bank classes, we are testing also how well our bag implementation performs. On larger programs that store hundreds, thousands, or millions of items, we may want to test several different implementations of our interfaces to see which performs the best with the usage described in the specific example.
Okay, so that's a quick synopsis on this first chapter of getting us a chance to see how things work with bags. And so with that, I think that's a good ending spot. There's a few other things that are in the lecture notes, but you can feel free to look those over. So Thursday, make sure you log in with your computer that has Eclipse, that you've downloaded these things. And if you have some problems getting it integrated into your Canvas, let me know. So I see 1 Mac, 2 Macs. Do you have a Mac or a PC? Okay, I do too. And so there's a slight differences of how the operating system engages with Java and Eclipse, but since we're all using the same platform, I think it should be relatively straightforward. Okay, all right. Well, thanks a lot, you guys. I hope you guys have a good couple days, and I look forward to seeing you all on Thursday.